Welcome everybody to this webinar. This is a very special webinar because we're going to be talking about something that's not highly technical. You know, how do you cook TCE out of clay or anything like that? We're going to talk about the challenges that we've had during the pandemic, COVID pandemic. As a group, TRS has over the last couple of years operated close to 20 thermal sites, and many of them in Brazil. So today we'll be talking about the ones in Brazil, and you'll be meeting Thiago and Jake. One of the things that is just a challenge is when you're doing a thermal project, you're heating up the ground, you're making the chemicals volatile, and when you do so, you have to extract them and you have to treat them. So you can imagine that we had projects in different stages of implementation. We had projects where we were drilling holes to put in electrodes or heaters. We had projects that we were constructing where we had as many as 10 or 15 people pulling these cables and laying them out, you know, between the power control units and the individual heaters or electrodes. We had other sites where we were building the equipment or assembling the equipment. And then there were sites in operation. And all of a sudden you have this COVID challenge saying you cannot travel or you cannot be more than a couple of people at the site at any one time, you know. And so how do you essentially deal with that when you have clients that still have tight schedules that want to be finished at a certain time? The other thing that happens is the price of everything increased, right? The copper cables got more expensive, iron pipe got more expensive, but clients don't want a price change. So that's the topic of today. We will start by hearing from Thiago. And my first question for you, Thiago, essentially is, if you don't mind giving us a little introduction about yourself and why you're interested in thermal remediation.
Good morning, Gorm. Good morning, Jake. Thank you so much for the invite to be here today. First of all, I would like to apologize to you all for my English. You know, it's not my mother language. My mother language is Portuguese. I hope you all can understand me today. Good morning, everyone who's in the US. Good afternoon for who's in Brazil and in Europe. So as you mentioned, my name is Thiago. I've been on the remediation market since 2001. I've worked with mainly all the remediation technologies, but for the last 13 years, I've been mostly focused on thermal remediation. I'm responsible for the thermal remediation sites from TRS and Docstore in Brazil.
Yeah. Jake, if you wouldn't mind letting us know your role.
Yeah, thanks. Thanks for having me, Gorm. Thiago, your English is great. I tell you that all the time. Good morning, everyone. I'll say good morning. I am in the US, the West Coast. So my name is Jake Seaman. I'm a senior engineer at TRS Group. I've been working for TRS for over 13 years now. And I've been working with Docstore since 2016, so about 6 years. And I'm pretty much responsible for all the design, operations, implementation of all the thermal technology and projects that we do at TRSDoxor.
Fantastic. Then Thiago, I'll go back to you. If you don't mind telling us a little bit about your company in Brazil, you know, and also essentially how you learned about thermal remediation, what your philosophy is down there.
Okay, so Docstore was founded back in 2003, so it's almost 20 years now. And when we started, you know, nobody used to talk about thermal remediation, but in Brazil, of course. After that, we were doing some work for a client of us, and they had this thermal disruption unit, like this rotary oven to treat soil, and they had this big problem. The machine wasn't working. They had to do a maintenance on that on a short time, and they knew. You know, my background was before I worked with focus on remediation. And my background is automation, so industrial automation. So this client of us called us asking for help, and I started, searching for thermal disruption on the internet, and I found TRS. So I got in contact with David Fleming back then, and David said, "Look, we have a webinar, not a webinar, sorry, presentation in New Jersey next week." So I took a plane from Brazil to New Jersey. When I got there, and I saw that you could treat soil and groundwater without removing the soil on site, it was just amazing. I wasn't expecting that. And that's when we started, that was our first contact with TRS. That was back in 2008. And then after that, David came to Brazil, Jerry came to Brazil. Those were the founders of TRS. And we took them to some sites in Brazil. They saw what we could do. And that's when we started TRSDoxor in Brazil. It was back in 2009. So we opened the company in Brazil in 2009. As you know, thermal sites take a little bit of time to really happen. So it took us almost 3 years to sign our first contract in Brazil. And nobody used to talk about thermal remediation in Brazil back then. So that was really the first thermal remediation site using electrical resistant heating in Brazil. And since then, we've been increasing a lot the number of sites that happen every year. Back in 2019, the environmental agency in São Paulo, the state of São Paulo, they forced everyone to have ISO 17025 to sample groundwater. And we were the first one, and I think we are still the only ones that have the warm groundwater sampling certification. That was really huge to us. We could prove for a regulatory agency that we can safely and sample groundwater, and you can have trustable results. And now in 2022, we have done 11 thermal sites, mostly year age, and we have 7 active projects, 7 electrical resistant heating projects, and 1 TCH, thermal conductive heating project going on right now. So we have 8 projects, 8 active projects right now.
Can you show us just one site and explain the driver behind cleanup?
Sure, I can. One of the main drivers in Brazil was really the real estate, so redevelopment. There's a huge pressure for these areas in São Paulo. So you can see this was a really big site. We installed 468 electrodes, if I'm not wrong. We have to divide the site in sections because we needed so much energy to treat that site. We wouldn't have all this energy available on that neighborhood. So that's probably, it's been the main driver. It was the main driver. Nowadays, I can see a little bit of change on the mentality, especially on the industry. So they've learned in the past that you better spend more money up front and really solve the problem, treat your contamination sources using thermal, instead of trying other technology, especially in Brazil, that we have such a tight clay most of the place. So it's really hard to use other technologies. And that's one of the reasons why thermal has been really successful in Brazil, and it's been more and more sites going on.
So you definitely need to clean the sites because, a couple of years after you're done, houses will be built and there will be vapor intrusion if you don't do it right.
Exactly.
Jake, I know your role involves helping with the tech transfer, right? Training the Brazilians how to do this. would you mind showing us a few more details of what that entails, please?
Yeah, absolutely. So with thermal technology, it's important to get to temperature within 2 or 3 months. We want to heat the site up fast because that's the most efficient. So the infrastructure is really important. So the first thing that we had to teach Docstore was to build really good electrodes, and that was our primary focus at the start of the tech transfer. So here's just some photos. And when you think about it, we're working in Brazil, it's different than the US. So there's different machines, there's different ways to do things. So we just have to make sure that we're still doing things at a high level, even though it's a little different. And then the next slide here, we have the other thing that we did with Docstore, which was really impressive, is that we had to build a power control unit. We call that our PCU. And TRS basically we sent over our specifications of, this is the unit that we think would work best in Brazil, and Docstore built it. They built it from the specs, and that's important, because the PCU is distributing the power to all the electrodes. So the second stage, the second container here, the one with the little towers on back. Yep. So that's our condenser cooling tower skid, and that's going to assist with the vapor liquid treatment side of the system. And same principles apply, is that we sent the specifications to Docstore, and they built it. So this project here is really cool. Davi took his drone out, and we did this right in the middle. Most of our projects are right in the middle of Sao Paulo. It's a really big city. It impressed me a lot the first time I went. I was just in just the size of it.
Cool.
Yeah. And then the last thing that needs to be transferred, right here, is health and safety. So one reason we partnered with Docstore is because they did have a very, they knew the importance of health and safety also. But in ERH and thermal sites, health and safety is just, there's different details that you have to be aware of. This right here is that same site that we just showed you, and it's our guys in a subway tunnel doing step and touch voltage testing for an ERH site. And you have to do step and touch voltage on ERH because you have to make sure that there's no stray voltages that are hazardous. And the tunnel was being constructed during operations. It was being done far enough away that we weren't terribly concerned that there'd be problems, but to do our due diligence, we went over and routinely were testing voltage and making sure that everybody was safe.
Awesome. So let's talk about the Corona thing that hit you, Thiago, down there. Can you explain? In Brazil, we know it's a little different. It took a little longer in Brazil for the COVID to start, I think, but when it came, it really was there for sure. How did you manage? Because you had multiple sites in different phases.
It was quite hard. As you mentioned, there was many different sites in different phases. The good part was that the environmental agency in Brazil, they considered remediation on sites where you have a possible vapor intrusion problem or any kind of risk for human health problem. They considered that the essential service. So we were able to work while other companies in other areas couldn't do it. So on a site like that we had, trenches being open, we couldn't just leave the site and let all those trenches open. So we were able to finish the sites. There were sites that we were working on industrial facility, and there were other companies working on the same site. So we had to synchronize because we couldn't be everyone at the site at the same time. So we had to synchronize. We had to rent cars for every single employee because they couldn't share the same cars to go to the site. It was quite tricky, and there was sites that we couldn't have more than 2 people from our side on the site. So we had to extend a little bit the work. It was quite tricky. It was pretty tricky, but we were able to finish all the sites on time. We did have to postpone a little bit one site because we didn't started drilling by then, and it was under a residential building. It's five towers. It's over 1,000 families living over the treatment area.
Yeah.
And we really couldn't get inside that site during the first months of COVID. But after a few months, after the few shots of vaccines, we were able to start working again.
Yeah.
Yep.
This one you definitely couldn't just leave like this, right?
No, we couldn't. That was a parking lot under a building. We couldn't do it. We couldn't leave it the way it was.
Yeah. Whereas this one is in better shape.
Yeah, this one is the one that I mentioned to you, that it's an industrial site. It's a multinational German company, our final client. And we always work for consultancy companies, but the final client in this case is a German multinational company. And there were other companies working on that site, so we had to schedule with them because we couldn't be at the same time as the other companies on the site. But we were really close to run the site, and so we were able to finish and run that site during COVID, during the first months of COVID.
When you turn it on, how many people do you need at a site like this?
On a site like this, when we do the commissioning, we would usually have at least 4 people helping on the commissioning, and usually somebody from TRS would come down and help us on the commissioning too. We couldn't have that on some sites. Travels were not allowed. So on that side, we had 3 people doing the commissioning, plus 2 online that were helping us, checking all the data so we could increase power, make sure everything was safe.
Okay. Jake, must have been more tough for you, right? Because you used to be able to just jump on a plane, go down there, be there, help with this startup, take data, write them down, and so on. How did you keep track of things as things were happening and you couldn't travel?
Yeah, like Chago mentioned, I generally go down for every startup, and in this situation, I couldn't for this one. So luckily though, like TRSDoxor has already had 8 projects under our belt that we've completed or almost completed, like at the start of Corona, the COVID pandemic. So we had a lot of systems in place for good communication. I knew the field staff very well. So these systems just became more vital during the pandemic. We have group chats for every single project. So I'm sitting on every project. I'm viewing what's going on. I'm asking questions and I'm seeing the photos. And then here is a screenshot of our condenser page from the control system. So we have a remote control system that I log into pretty much every day. First thing to check is make sure that the vapor liquid treatment system is running. Look at temperatures, look at data, look for just make sure everything looks okay. After that, I kind of scroll over to the power page, and then we make sure that we're getting energy into the ground. So make sure that it's also going where we want it to go. That's really important. We don't want to waste energy by putting it in an area that may be already clean or just doesn't need that much energy. And using temperature data as well to review energy input versus temperature and how that's going. So all these systems were in place and I had been doing them. The big thing is more calls to Chago, more calls to the guys on site, making sure that standard operating procedure documents were available and translated into Portuguese for the guys. And then we just kept going along the way that we had been going, but just a little bit more remotely.
Awesome.
Yeah.
Thank you for that. And then Thiago, before I ask you one more question, I just want to remind everyone, you can type in questions. There's a little thing that pops down that says Q&A. That's the place. And the more good questions you put in, the better. We will just be talking for another maybe 5 or 10 minutes. And then if there are some questions, we'll be trying to answer them. Unfortunately, you can't speak to us, but you can hopefully write your comments or your questions. So, Thiago, one of the things when we're doing thermal remediation, there's always a focus on the cost of it, right? How were you able to control costs during all this with all these changes?
Well, costs really impact everyone, right? Especially the basic materials like graphite, steel shot. Those are things that we cannot control. But as a company, TRSDoxor, we decided together with TRS back on the beginning, and I think right now it shows it was one of our best decisions. We decided to manufacture all our power control units as a standard unit, and also the cables that we bring to the site. So we do have a lot of PCUs, a lot of material, a lot of cables that we can reuse site after site. So we were when the COVID hit us, we were in very good shape in material, talking about equipment and all the materials to do the field installation.
Thiago,
sorry, you said PCU. What is the PCU?
Well, PCU is what we call the powered control unit. It's the machine, if I can call that applies energy on the ground, and we can control how much energy we are applying on each electrode or on each heater. So that's what this equipment does.
Is that the stuff on the right of this picture?
This is the stuff on the right. This is for a thermal conductive heating power control unit.
Yeah.
So we manufacture that ourselves. That was part of research and development between Docstore and TRS. But because we had all those equipments and a lot of those cables and especially cables that did increase a lot the price in the last couple of years, we do have a lot of that, and so we were able to kind of don't increase too much our price. So we had to build a little bit more. Every site we have to buy a little bit more, but we were able not to spend all that money, so that was good for our clients, and we could keep costs down.
Very good, very good. So the final question I have before we open it up is to you, Jake. How about this? Has this just been a one-way street where TRS has been teaching Docstore what to do, or has it been different than that?
Oh, 100%. No, I'm just kidding. We get to it's pretty great. We get to learn back and forth, and Docstore, as Thiago just mentioned, Docstore was a huge part of our R&D efforts for TRS in the thermal conductive heating area. This is a video of our first project for TRSDoxor for TCH, thermal conduction heating, TCH, and they were part of the R&D, and we actually started building that PCU that you showed on the previous slide, and started our first project during the pandemic. So talking about translating documents, getting information over to them remotely, all of that during the pandemic. It was challenging, but it was a good challenge, and the result was great. Docstore did amazing work on the construction and on the installation. So it was just really beneficial being able to use some of their resources at their warehouse to install and operate our first pilot test, and then from there we get to see this site. And it's actually a video. If you want to play it, it'll show, kind of span out the entire site.
Yeah.
Another part of kind of that that information transfer is, I'm part of the best practices team for TRS group. And so when we're evaluating a new material that we can use, maybe a more effective option, maybe a more cost-effective option, safe or something like that, I'm always bringing my experience from TRSDoxor and into the discussion with the other engineers. I'm saying, well, this is how we did it, in Brazil. Is this, can we do something similar? Is that possible? And vice versa. When I see a new installation or a new project in Brazil that TRSDoxor needs to do, same thing, I go back to the best practices team and get that information from them. So it's very synchronized and it's very back and forth, which is a lot of fun.
Awesome. I have a silly question. How come one area is blue and the other one is black?
Different stages of the construction. So like Chago was saying, during the pandemic, we all know this, materials were difficult to get. So
Yeah.
we started this first area, we'll call it the blue area. We were able to start this area first because we got all the materials, they arrived and everything like that. What you're seeing, the blue, that is a waterproof membrane, so that we don't get any rain or water infiltration on TCH site, because TCH, we try to thermal conductive heating, we try to dry out the site in most cases. And in this case, we are trying to dry out the site. And so that waterproof membrane is very important. You can see in the far area, you can see some brown as well as some black. And the black is oh yeah, there we go. So the brown is wool, mineral wool insulation, so that we get a nice, nice warm coat around the site. I know you've used that analogy before, Gorm. So we have mineral wool insulation, and then the black is the initial liner that we were using to kind of keep all that insulation nice and protected. And then we were going to install the blue waterproof membrane over the top of that.
Cool. Adam is asking, he's really watching because he saw in this previous shot, he saw some of the probes were over 100 degrees, and he's asking, why would you need to be above the boiling point of water?
Oh, that's a great question. So this TCH site that we're operating, this is a TCH screenshot, so our thermal conductive heating site, and certain contaminants require you to get over the boiling point of water, and in this case, that's what we're trying to do. Additionally, these temperatures that you're seeing here, these are all temperature probes that are next to the heaters. So our heaters can get upwards of, Gorm, I think it's 900 Celsius.
Mm-hmm. Yeah.
So our heaters are running at 900 Celsius, give or take, depending on it. And so you have I think it's like 5 inches is the distance between our heater and a pipe that's in the ground, co-located with the heater. And that co-located has a high temperature thermocouple, or RTD, a temperature measuring device. And so we're measuring that temperature. So ideally, if you look to the SCR6, it's the middle one on the left. That one's at 550 Celsius. So that one's one of our performing one. This is early on in operation. So.
Mm-hmm. And I know this site in Brazil was and a site with some oils and different things. So it was not a PFAS site, but there's a question. There's a question from David asking, can you use this for PFAS treatment in soil?
Yeah, we are using it for PFAS, and Gorm, I think you definitely know a lot more about the site that we just completed.
Yeah,
we were doing some PFAS research. I think it'd be better if you spoke to that one.
Okay, yeah, it's definitely the thermal conduction heating technology that is what you're seeing this screenshot of, and this is a TCH thermal conduction heating site, right? These are electrical heater elements inside a steel pipe, and you can put them closer together than this. And as long as you are above the water table, you can remove all the water by boiling it, and you can get to temperatures of more than 300 degrees Celsius. And for PFAS, we have found that we need to get about above 350 Celsius before we get really strong reductions. And we've done that in the laboratory. We have done it in the field now in Alaska. We finished an ESTCP demonstration. That's a research funding program. We finished that right around Christmas time, and we have our samples, soil samples back showing very, very good reduction in all the PFAS compounds we can measure in those soils. So yes, we can do it above ground. Like what you're seeing here is actually a vapor cover that is, and there's a mound for insulation purposes. But sometimes we treat a pile of soil that looks just like this by sticking heaters into them and heating the soil until the PFAS has been extracted. We can also do it in situ in the vadose zone, so above the water table. We can do the same. And we have the second project is going to be performed at Beale Air Force Base in California this summer. So that was definitely a yes to that. I see a few more questions coming in. Nick is asking, given the rising cost of commodities like copper, have you had theft, and has that been an issue of at your Brazilian sites? And what do you do to make sure you don't get break-ins? What kind of security systems do you have?
We never had a big problem in Brazil, even though we know there is a real big value on all those cables that are laying over the site. There were sites that we had millions of reais in cables like this one. There's a lot of money in cables right there. Mm-hmm. So we do have most of the sites. We usually have a security guard 24/7, and we also have sensors that if somebody get in the site and to try to steal something, first thing is safety. It will shut down the system. There is no risk if somebody tries to grab a cable or something. So we turn off the system. And at the same time, we are recording, we have cameras, we have alarms on our phones. So there are ways that we can monitor the site, make sure that we don't have any big problems with thieves or working, and especially if somebody don't get hurt.
Yeah.
Right. But we never had issues in Brazil. Luckily, from the last, since we started, we never had like a big problem.
That's fantastic.
There are a lot of signs around the site too, saying warning, electrical shock,
yeah.
Things like that. And for anyone that's never seen those in Brazil, they're much scarier. They say risk of death, and it's very intimidating.
Yeah, very good. One more question here. How do you determine the progress and the endpoint of treatment short of redrilling and sampling? That's a very good question. And I don't know, Jake, if you want to take it.
Yeah, I can. And Gorm, jump in as you want. I've worked with you on this subject a lot. So with progress and kind of when to turn it off, that's a very common theme for thermal sites, because we're putting a lot of energy in the ground. It's a high labor intent. It's a very money intensive operation until it's done, and you don't want to waste heat or waste energy. So we look at temperatures around the site. I like to look and make sure that I'm above it's called the azeotropic boiling point of certain contaminants. And we want to basically be heating above those boiling points for a certain amount of time. So that's one aspect that I look at. The other thing we look at is did we put in the amount of energy that we thought we were going to? So we have models that TRS has developed over 20 years and has been even improved as of late with Gorm helping out. And so these models they're really accurate. They're really good models. And with a lot of unknown variables, they're very accurate. And so we look at how much energy did we predict, how much energy have we put in? So, energy density, temperature. We also look at the vapor concentrations that are going into our vapor treatment system. So we can, the best, I don't have a graph, but I'd love to show a graph. The most ideal case is you just see a line, it goes up and then it comes back down. And once you see that peak, you think, okay, so we just got to keep going, and we wait till it gets closer to zero or asymptotic. And at that point, that's also a good sign that we should sample. And then lastly is soil borings and monitoring wells. So let's sample the groundwater and see where we're at versus the goals of the system. And if we're not there, often what happens is we'll sample, and at that sampling point, we'll be able to turn off, over 50% of the site. And at that point, we can, with very common practice at TRSDoxor is we turn off the electrodes on the areas that are clean, and we will increase and kind of target and boost the power to those areas that are still slightly above the goals, and in order to try to finish those up faster.
Very good. Yep. Thiago, I have a little weird question for you. How come all the projects in Brazil are around Sao Paulo? Why not in other places of Brazil?
Oh, I would say for two main reasons. One is São Paulo was had the most industrial development back in the 60s and 70s. And we also have the most active environmental agency. So those two things combining being the state with more sites to clean up. And São Paulo is, of course, the city that with more redevelopment going on in Brazil. So there's a big pressure for those old brownfields to redevelop.
Okay. Some of us would prefer to visit like the northern part of Brazil where the windsurfing is really
Yeah.
so we'll work.
I would prefer to have sites over there.
Yeah. All right. I have a really good question from Eric. Can the process be done on soil located below a parking lot without disrupting the use by the tenants? So can you treat underneath something if you can't be on top of it? I
think we've been quite good on that, I guess, right? Jake, we have done work. We're doing a site right now that's under an active building, and we are treating really under the elevator. So it's quite difficult. It is possible, of course. During installation, we need to install the electrodes. So we have to block part of the area to be able to do all the installation. We can do the installation below grade. So after we do the installation, we can open the area and everybody can use it while we are heating the site. So yes, it is possible. We've done work under active buildings, under an industry, close to a subway line. So many different sites on a public street in Brazil. So we've done many different sites.
Do you ever get subsidence, shrinking of the soil, so you get cracks in the building?
With ERH, usually you don't get that. You can have that with TCH. So if you're working under a building, personally, I wouldn't recommend TCH. I would go for ERH. Once on a site in Brazil that has like a really plastic clay, it was like kind of dark gray, close to a river here. We did have a little bit of settlement. I would say something like 5 centimeters. It was an open site. We didn't have any problems with that. But we definitely, if it's an active building, or we definitely would do a building survey before we start and during operations, making sure that we are not, causing any structural problem.
Yeah. And I can maybe add to that real quick. our friends at Terratherm would say they've treated many sites under buildings with thermal conduction heating as well. So just to be fair, you can do it with both with ERH and with TCH. When you do it with TCH, thermal conduction heating, you do not do it if there are any high organic layers like a peat layer. You would risk having some of that peat burn off because the heaters get hotter than an electrode. If you have, to both technologies, you would probably select ERH more often. But I just make sure we don't claim that you can't do it with TCH. You just have to be very careful, and you can't run the heaters as hot, so you risk burning off too much of the carbon. Very good. Of course, there's another question about utilities. Do you have worries about damaging utilities which are inside your or close to your treatment area?
Oh yeah, if it's inside of the treatment area, definitely. That's something we do need to monitor during operation. We have a site right now that we are on the design phase in Brazil. That this industry has PVC pipeline. It's water drain line, but it's right over the treatment area, and they cannot change that for concrete or steel. And so we are discussing with them how we're going to monitor. So we're considering installing thermocouples inside that pipe and doing ventilation or pushing water through the pipe every now and then during the operations, so we make sure that we don't really damage that pipe. So it is possible.
Yeah, and I have experience. I had a site in North Carolina where there was the fire suppression system ran through our site, one of the main pipelines for it. And we ended up daylighting the section of the pipe that ran through our treatment volume, and we were ventilating around it. And there are lots of other methods that we can use to protect utilities. TRS is very experienced in that. We've done it quite a bit. I've done it at least 3 or 4 times on projects in my career, and I know the other engineers have done it a lot too. So,
yep. Very good. I think we have addressed most of the questions. I see one from Lee that we haven't talked about. With ERH, can you treat sedimentary bedrock?
Yes. Yeah. Sorry. Read through the questions as well. We can treat sedimentary bedrock. I know that we have a paper out about doing really effective treatment in sedimentary bedrock. I believe Emily did a lot of work on that. I don't know the full details of the paper, Gorham. Do you have more information on that?
Yeah. Well, I know we have treated a number of sites with the sandstone and siltstone and shale, including even at Redstone Arsenal that is a limestone, karst limestone. We treated 6 or 7 different source zones at just one site. So we're definitely over 10 cases for having used electrical resistance heating in bedrock. It's 12 or 13 total. As long as it's not stone, as long as it's not crystalline bedrock like granite or gneiss, where there's no water, we have had good luck heating. And it's all about, we're not treating coal tar there, right? We're treating chlorinated solvents. So we just need to get up to the boiling point of water and vaporize off the solvents, and then they travel through the cracks, and we have enough extraction wells to penetrate the cracks or the fractures. You can tell I'm not a geologist, right? And then you extract that. One of the challenges in bedrock is how to sample and know that you have actually gotten everything. It can be really expensive just to drill, a hole that's good enough to get a good core sample. Then you have to crush the core. Now you have to extract it in methanol. Now you got to analyze that. But yes, the thermal piece of it, cooking the bedrock and sucking out the chemicals, has been proven with both thermal conduction heating and with electrical resistance heating to be effective. One more and probably the final sample. Can you provide some detail or final question? Can you provide some detail on the process for hot soil and groundwater sampling?
Yeah, so with hot groundwater sampling, we generally turn the site off. We stop heating a few days before we do the sampling, and that's to just it's an added level of safety. You have to be careful whenever you're sampling hot groundwater because you don't want to change the pressure very quickly, because then it can vaporize. And so we have a monitoring wellhead that's specific for thermal remediation that we've designed, and that provides a safe avenue for us to take the hot groundwater to do the hot groundwater sampling. And so we have tubes and everything, and we generally use I'm forgetting the name of the pump. It's the pneumatic pump that's going to draw the water out of the hot water out of the ground and out of that monitoring well. And then that hot water, it's hot, it's very hot. It goes through a cooling loop that's usually made of copper or steel or stainless steel, something like that. So we put that cooling loop in an ice bath, and then we cool down that water. And then from there, that water goes directly into sampling vials and gets sealed. And so if you think about the process I just described, it's very important that we're not letting it in contact with air at all. We're keeping it very enclosed, and it's going straight to the sampling method. So we get really good results that way.
In the end, Gorm, basically it's the only difference from a low flow sampling for hot water, warm groundwater sampling. We don't measure the water level because we cannot open the well. And we cool down the water before we go to the flux to equalize the parameters, and then collect the groundwater. So it's pretty similar.
And when it comes to soil, I can answer that real quick. You can drill down, and then you have a sleeve, like a steel sleeve that you press down, and you capture the clay or the soil inside of it, and you get it to the surface, and you immediately cap the ends so that nothing can run out of the coil. Then you put it on ice, and when it's cold, you open it and sample it the way you do it if there was never any heat there. And there's been studies by Patel and others with tracers injected to make sure we don't lose the contaminants that way. So it's been proven, and it's been accepted by the American EPA, hopefully by ZTSB as well. You take hot samples and you can analyze it. Yeah. Very good. And thank you everybody for the really good questions. We turned a little bit away from COVID when we were discussing this, but it was a good thing to talk about. And let's hope we don't have to deal with COVID 20 or 21 in the coming years. And thank you so much, both Thiago and Jake, for this and for participating.
Thank you.
Yeah,
have a wonderful day. Thank you.
Bye, everyone.
Bye, guys.